Did you know that you can use quadratic functions and optimize the best selling price when you try to figure out what would be the most optimal price for selling your products? Or you can find the maximum revenue or the best optimal profit? In this video, we're going to walk you through that, so stick around. My name is Bogdan Marzewski and I welcome you again to watch my videos where we make quadratic functions easy for you. Let's dive in. So in this word problem, we'll be focusing on finding the best selling price using a simple quadratic strategy. So let's break it down. There's a word problems that we have to identify the data. We have to make sure that we understand every single term so that we can start putting together. So the story goes like so. There was a student council and then they sell hoodies to raise money. So that's a very sort of a typical situation. But the information further down shows that they sold 60 items, hoodies in this case, for $20 each. So when you're selling items per unit price, you can sort of see how much money was generated through the sale. So that's the revenue. But they were looking at the previous fundraising events and they noticed patterns. Mathematics is about patterns. So welcome to this beautiful word. And each time they raised the price by $1 or multiples of dollars, two fewer sales were realized. So this is sort of the strategy. Now we have to manipulate the price and we will encounter less sales, but still we hope to get the best possible revenue using quadratics. So the question here is determine the selling price that gives the highest revenue. So by tweaking the price and the number of hoodies sold at that price. So we will optimize using quadratics the best revenue when we change the price. We're actually going to increase the price. We will sell less, but still we'll make more money in the end. And then we're going to use the concept of wholesale pricing to get the maximum profit. So in this question, the key focus is on establishing what is the revenue, how do you find profit, and how do you incorporate those details when working with quadratics. Okay, so this is how you break down the word problems. First, you facing a huge paragraph, sometimes confusing words, everything is messy. So let's break it down to make it easier, as we always promise to do that in this video. So given information that we start with, 60 hoodies, the number is fixed, $20 per item, fixed and provided. Then the concept talks about every dollar increase so that you can add $1, right? You can increase the price by adding $2. You can increase the price by adding $3 and so on. So when you increase the price, you increase by increments of $1 each time. And then what happens? You would lose 2 customers for every dollar that you increase the price. For example, if you add $1, you would use the pattern 2 customers per dollar would walk away. If you add $2 to the price, you would lose 2 customers by that multiple. So 4 people will stop buying. So that's sort of the pattern that we observe here. And quadratic function is a beautiful application that allows you to work with optimizing the best revenue by simply putting it into the quadratic formula. So we know that we have to find the best selling price somehow. We have to figure out how many items that would be needed to achieve that objective so that we can get the maximum revenue, and then the profit as an extra addition to this question, so that makes the question a little bit more challenging and interesting. So, plan of action now. Usually you introduce a variable. So typically X will be the variable used in this question. You can think of any letter you want, it doesn't matter. It's your decision. Remember, the way you learn, you have to follow your best practice. So, for example, if X would represent the number of multiples of increments, that same variable would be utilized to use it for the number of items, multiples of items sold and customers loss. So those are the multiples. X is like a counter. Could be 1, could be 2, could be 3, etc. So since we need to increase the price, we say 20 plus X because it's multiple of $1. So 20 plus $1 times X. Hopefully that makes sense. 60 is the starting number of items, and then we lose 2 cells. So from 60 hoodies, we expect to get the number down. So minus 2 customers every time you increase the price by multiple of $1. So 60 minus 2 times X. And the revenue, quick reminder, the revenue is the number that is generated by a product. Price per unit multiplied by the number of items sold. So for example, if I have ice cream that I sell $2 per ice cream and I sell 10 ice creams, so 2 times 10, 20 is my revenue. It is not my profit, it is the money generated from the sale. So since this looks like already something that you can recognize, you have a binomial multiplied by another binomial. So that should remind you about a factored form of a polynomial, quadratic polynomial. So this fits into quadratic functions because this is the second degree function. When you're thinking of expanding it, you would get negative 2x squared. So that sort of brings you into that quadratic functions world. So we're going to use this vertex formula, right? Working with this quadratic function to find the optimum value for x, which will then reveal how much should be the new price so that the revenue generated would be maximum. We know also already from the setup of the revenue that this parabola would look somewhat like so. Open, down, so there is a vertex. There is the highest point, which would represents the highest revenue in this case. So let's do some math now. Now I understand what the problem is calling for, what is given, what is the meaning of the revenue. So let's focus on that at this point. So by introducing the variable, we identify the new price, 20 plus x. We identify the number of units is 60, the starting point minus 2 times the multiple, x. So the revenue is a product of price per unit times the number of units sold. The Q, quantity, P is the price. It doesn't matter which letters we're using, so don't really focus too much on the letters, but focus on the concept. So this revenue function reminds you or is already familiar, you see the pattern here. We observe the product. Now we have the connection made with quadratics. So this revenue function is pretty much identical. So if you want to use letter Y, for example, to generate equation and letter X, because that's the most familiar environment, go for it. You don't have to necessarily use letter R to declare it as your revenue. Letter Y is fine. In fact, any letter is of your choice would be just fine. So if you were to expand this quadratic, this product, you would get this expression, right? So you remember the formula. You would go 20 times 60, 20 times negative 2x, 60 times x, and x times negative 2x. So this is the expansion of the product. So that makes sense. We already have videos on how to work with multiplying binomials. If you need to watch that, beautiful. If you already know, just follow the steps. When you simplify this, now you get perfect sort of formula that reveals this is a quadratic function. You have a coefficient, which is equal to negative 2. You have b coefficient, which is equal to 20. And there's a constant value, which is equal to 1200. So you can sort of relate right now that we have generated quadratic functions. We can now find, by using different methods, the vertex location. And the vertex would be represented by the revenue value. X is not how much is the new price. X is the increase, or multiples of $1 increase in the price. But directly X is not really saying that the price is so much. The X number that you find would be utilized to use right here for the price, 20 plus X. So when working with quadratic functions, if you have it in standard form, you can utilize this vertex formula to find the coordinates of the vertex. So you could do that, or you can use this factored form, which is much easier. In this situation for me, I would rather use that because you can find a 0 value for each and add them together divided by 2. And you can get the vertex location as well. If I were to use this formula that I have in front of me, so I have to go negative b over 2a. So substitution, negative 20, right, divided by 2 times a, that gives you 5. So 5 is the number of multiples. So that is not the price. This is to be added to 20. So 5 times $1 is $5. 20 plus $5 is 25. So that would later reveal the new price. So on this screen, we go back to this revenue function, understanding that X is 5. So the new price is 2 plus X, and X is multiplied by $1 because that's the multiple of dollars. So this is why you add $20 plus $5 now to get the 25 in dollar value. Now, for number of items, we have 60 minus 2x. So x is just a number. It represents the multiples of the changes that we have to implement. So 60 represents the number of units sold, hoodies, minus 2 times 5. So minus 10 hoodies. So the maximum revenue is going to take place when the price is $25 and the number of hoodies sold is 50. So we would reduce the number of sales by increasing the price, and still that's the optimum value This is the location of the vertex. So your parabola has that opening down, and the vertex is located, and the value of the vertex is 1250, and the price value is 25. So that is and the number of units sold is 50. So hopefully now you know how to use a quadratic functions, whether this is in standard form, factored form, to find the location of the vertex, which is representing the optimum revenue in this particular example. So the profit concept now. Profit is like how much money was made in the process. In order to find a profit, we need to know the cost of the purchase of a unit, and then how much you're selling for. This is the markup, the difference in price. So let's say you buy a book for $10 and you're selling for $20. So the profit is the difference, 10 subtracted from 20, and that is your profit. You buy something for $5, you sell for 15. The profit is 10. So this is why we have the profit defined as revenue minus the cost, the wholesale price, if you will. So if we're buying hoodies at $10 each at wholesale price, we sell 50 because that's expected number to generate the best revenue. So this is the cost of the purchase, the cost of acquisition. And then from the profit, you subtract the cost. From the revenue, you subtract the cost, you get the money value, which is defined as a profit. So hopefully this makes sense. Profit is the total money generated minus the cost that was involved in the process with acquisition of hoodies in this case. So summarizing, we found the optimal price in this question to create the best possible revenue. We were able to establish what is the number of items to be sold to get that maximum revenue. We were able to identify the value of that maximum revenue by simply multiplying best number here with the best number from that part. And the profit realized when the cost of purchase was $10. So hopefully this question gives you clarity. Now you become an expert in finding the best selling price when you're doing other questions very similar to that. So practice questions. Hello, let's do implement skills so that you know how to tackle any questions. This is a typical questions in mathematics when they find optimal price, optimal revenue, or best profit in your math course. Thanks for watching. We'll see you again. Bye for now.